Hello everyone, we are discussing Bernoulli's equation and in the previous lecture we have developed this. P plus half rho V square plus rho GH is what? Constant. This is Bernoulli's equation. Now let's see some applications of this equation. If H is kept same, for example, look at this. We have a pipe, liquid is flowing in this through the pipe in this direction. Pressure at this place is P1 and pressure is P2 at this cross section. H is same. Height from a given base, let's say this is ground. So from this ground, if you go for this height or you go for this height, they both are same. This is the place where pressure is P1, this is the place where pressure is P2, this is the place where velocity is V1 and this is the place where velocity is V2. When water comes out, it comes out with V2. Let's see first, without my help, if you can answer this. P1 is P2 greater than P2 or less than P2. Which option is correct? A, B or C? You have a pipe with different cross-sectional areas, A1, A2. Pressure at this place is P1, pressure at this place is P2, velocity at this place is V1, velocity at this place is V2. Then which option do you think will be correct? If without my help, I ask you to solve this question. The hint is, first hint is you have to use Bernoulli's equation. And the second hint is you have to use continuity theorem. Product of cross-sectional area and velocity is a constant. All types of answers are present. C, B, A. What is the cross-sectional area at this place? A1. This is A2. A2. This is A2. And you can see that A1 is greater than A2. And what is continuity? Continuity theorem tells us that product of A and V is a constant. So if you increase A, you must decrease V. A1 is greater than A2. It immediately tells us that V1 therefore should be less than what? V2. अभी बड़ी obvious सी चीज है, अपन continuity में इसको देख भी चुके हैं. I've told you that if you hold a pipe and you decrease the cross-sectional area of the pipe, you find that speed has increased. This was coming from intuition also, that V2 is greater than V1. Now let's take help from Bernoulli. If H is same for both places, then you're basically saying that P plus half rho V square is a constant. H is same, that means P plus half rho V square is what? Constant. Which means if you increase V, if you're going to increase V and keep the whole thing constant, P should decrease. Which means what? कहाँ पर स्पीड ज्यादा है अपने पास? तो जहां स्पीड ज्यादा है वहां का प्रेशर, जहां स्पीड ज्यादा है वहां का प्रेशर क्या हो जाएगा? कम हो जाएगा. That means स्पीड ज्यादा है, pressure at this place 2 is less than the pressure at this place. P1 greater than P2. Option B is the correct thing. If you understand this example, then write down yes in the comment box. And only 2 could produce correct answer. Now once you understand this part, we then can also use something like this. this is already visual. A1 is greater than A2 and things like this. In this particular pipe, if we connect these two small vertical pipes, look at this figure. This thing has two vertical pipes. Remember, all these cross-sectional areas, dimension-wise, they are very small as compared to these heights and all. I mean, it looks like that this much is the diameter and this is the height of the pipe. But remember, they are not of this large size. So, the question is, water is flowing through the pipe. In this, water level is up to this height. The whole thing is water. Let's say this height is capital H2. Small h was height of the cross section and capital H is height of the liquid column in this vertical tube. And height in this is H1. H1 and H2 are from the axis of the pipe. This one is H2. This much is your H1. Now tell me this. Which one is the correct option? Which one out of these three is the correct one? A, B, C. As water is flowing through it, height of liquid column in the first limb is H1, in the second limb is H2. Which option is correct for this question? Let's see how many of you will answer this part. Let me give you the hint. What is pressure? Pressure is H rho G. Everybody knows this. So if pressure is H rho G, this is P1, this is P2. What is pressure at this place? What is pressure at this place? P1. Look at this height. H1, and therefore P1 is H1 rho G. Similarly, pressure at this place is what? P2. This height, we're not talking about this H. We are talking about height above the axis of the water tube. This P2 is what? H2 rho G. We already know relation between P1 and P2. P2 is less than P1. P2 is less than P1. That means H2 is less than H1. समझना लिक्विड फ्लो हो रहा है, क्रॉस सेक्शन ज्यादा है, क्रॉस सेक्शन कम है. अगर क्रॉस सेक्शन कम है तो स्पीड क्या होगी? इंक्रीज. अगर स्पीड इंक्रीज होगी तो प्रेशर क्या होगा? डिक्रीज. यहां का प्रेशर कम है. अगर यहां का प्रेशर कम है तो यहां पर जो वर्टिकल हाइट है H2 वो भी कम होगी. This whole thing, this setup which you see on the board is called Venturi Meter. The setup on the board is Venturi Meter. You know what this Venturi Meter does? You can erect two pipes and then now you can measure difference of speed at this point and at this point using this Venturi meter thing. Note down this device is called Venturi meter. I hope you can see it. Now you've got 30 seconds to answer this very elementary thing, but you can. For a Venturi meter, find out H1 minus H2. For a Venturi meter, you need to find H1 minus H2, and we have been given speeds at both cross sections in the form of V1 and V2. Try to answer H1 minus H2 in terms of V1 and V2. It's an elementary task. Everybody can answer this. Well, answer in terms of V1 and V2. Only one correct response. Look, what I'm asking you is, I'm asking you something which is already present on the board. P plus half rho V square is constant. Use this. How do we use this? P1 plus half rho V1 square. P1 plus half rho V1 square at this place is equal to P2 plus half rho V2 square. You don't have to worry about H. For both cross sections, height from the ground is same. What is this P1? H1 rho G. Write down that H1 rho G plus half rho V1 square, and this thing is equal to P2, which is H2 rho G. H2 rho G plus half rho V2 square. Rho cancelled. We're looking for H1 minus H2. H1 minus H2 is coming half of V2 square minus V1 square divided by G. That's your H1 minus H2. That's what I was asking you. Simple use of Bernoulli's equation in Venturi meter. What is Venturi meter? You have a pipe with different cross-sectional areas at different places. At these different cross-sectional areas, if you want to measure pressure, then how do you measure pressure? You can erect these vertical tubes, and in these vertical tubes, if you look at the height of water column, then this height will give you the pressure. Height will give you the pressure. This height is related to speed at a given cross section in this form. If you understand H1 minus H2, then write down yes in the comment box. Although there was not much in this, but only one or two could answer this part. A very interesting use of Bernoulli is in the design of an airplane. When we design its wings of an aeroplane, then the shape, the curvature which you give to the wings is such that the top surface of the wing allows air to flow freely. Now, if it allows air to flow freely, that means you are increasing what? Speed. I'll look here. And look at this equation. Wing has a design of this type. So when air flows from this side, it can flow freely and it is being blocked from this raised portion. It allows a free flow. This is blocking of air molecules. Now, if this is V1 and this is V2, let's relate with this. This is V1 and this is V2. I said that it's an easy flow of air. It's an easy flow of air, that means V1 is greater than V2. You don't have to go and see an aeroplane for this. You can see any bird when they fly. Look at the shape when they're basically gliding. It will be better when you see when they are gliding. Look at the shape of their wings. You will find this type of curvature. So this curvature tells you what, that on the upper side, speed of air is greater than that at the bottom of the wing. हमने क्या सीखा? अगर स्पीड ज्यादा है तो प्रेशर क्या हो जाएगा? कम. इसका मतलब यहां का प्रेशर P1 और यहां का प्रेशर P2. P1 is less than P2. बॉटम पार्ट पर प्रेशर ज्यादा है. मतलब क्या हुआ? यहाँ प्रेशर ज्यादा है, यहाँ कम है. चीजें कहाँ मूव करती हैं? फ्रॉम हाई प्रेशर टू लो प्रेशर. दैट्स कॉल्ड व्हाट? लिफ्ट. एंड देयरफॉर दिस plane gets a lift. That's how wing of an aeroplane helps it in providing the lift. You can draw this figure. This arrow is for the lift. Lift is coming from this part. यहाँ पर एयर स्पीड ज्यादा है, प्रेशर कम है. एयर स्पीड कम है, प्रेशर ज्यादा है. हाई टू लो, हाई प्रेशर टू लो प्रेशर मूवमेंट gives you what? Lift. And you can see that that aeroplane on the runway, it has to move and acquire a certain speed. Only then it goes up. This is coming from this. When you develop a particular speed difference between top and bottom of the wing, you will get a particular difference in P2 and P1. P1 is pushing it down, P2 is pushing it up. So when you get a particular speed which gives you sufficient uplift which can balance entire weight of the plane, then only the aeroplane is going to take off. So that's the reason you have a long runway, so that you can acquire sufficient speed. The formula which we gain in terms of H1, H2 or in terms of P. This is the working of an aeroplane. Those who are interested can note down this figure. Write down working of an air wing. Working of a wing of an aeroplane. Simply write that. Now next is Torricelli's law. In fact, the same thing is with your ceiling fan. When blades they move, the design is such that air at the bottom of the blade, just my hand represents the blades of a ceiling fan. So when it moves, what it does, air at the bottom of the blade, it acquires more speed. If it acquires more speed, pressure decreases. Listen again. As it sweeps, air at the bottom acquires more speed. More speed means less pressure. So at the bottom of the blade, there is less pressure. At the top, there is high pressure. And air flows from high to low, and therefore you find that ceiling fan is blowing air into the room. So all this can be explained with the help of Bernoulli. And that's the reason we study Bernoulli's equation and all. If you understand the concept of wing of an airplane and this working of ceiling fan, then write down yours in the comment box. The way these things work using the concept of Bernoulli, then write down yours in the comment box. Next, write down Torricelli's law. Torricelli's law. What Torricelli found, he found this, that if you have a water tank, this tank is filled with water, and you make a tiny hole at the bottom. It's a tiny hole. Just so that you can see it, I'll make it a bit larger. This is the hole at the bottom. Now it's visible. And the whole tank is filled with water or any liquid which is incompressible and has no viscosity. Then when water comes out through this hole, V, what Torricelli found, is equal to root over 2GH, where H is height of liquid column in the tank. Let's say this is A2 and cross-sectional area of the hole is A1. If A1 is much smaller than A2, if you make a tiny hole, then what Torricelli found is that speed of water jet as it comes out is equal to what speed gained by an object during free fall. I hope you remember what is root 2gh. When you drop an object from height h, then through this height h, when it drops, तो जो velocity gain होती है, kinematics से याद होगा, velocity gain during a free fall is what? Root 2gh. Same thing he observed is coming from this tank also. अगर ये क्रॉस सेक्शन बहुत ज्यादा है as compared to this, तो जो वाटर जेट बाहर आ रहा था, it was giving this speed. Now we'll prove this Torricelli with the help of Bernoulli. Write down this, draw this figure, and then we'll write a few statements, and then we'll prove Torricelli with the help of Bernoulli. Draw this figure. Can you see the board clearly or is it blurred? Blurred, not visible. Just hold on. Good, good. Draw the figure and then I'll explain everything. Just draw each and everything and I'll explain every part again. What is Torricelli's law? If you have a tank in which you make a very tiny hole at a depth of h from the top free surface, then speed of water when it comes out is same as which it would have gained during a free falling condition. Our aim is to prove this with the help of Bernoulli's equation, but first write down the statement for Torricelli's law. If in a large tank, a tiny hole is made, then speed of water as it comes out is same as it would have gained during a free fall. From the same height where the top surface is from the tiny hole. Now look here. This Torricelli will basically help you in understanding how to use Bernoulli's equation. The way things work. Let's say this V is V1. Because this is A1, let's take it as V1. And since water is coming out, the top surface is also coming down, and it is coming down with speed V2. Water is coming out with speed V1. We have no idea what V1 is now. This is V1, this is V2. It's a continuous liquid, and if it is a continuous liquid, then we immediately say that A1 V1 is A2 V2. Product of this cross section and this speed is equal to product of this cross section and this speed. We'll need V2, and this V2 is A2 upon A1 multiplied by, just a second, V2 is A1 upon A2 A1 upon A2 multiplied by V1. A1 upon A2 into V1. That's your V2. Well, the one thing which you can see is V2 is much smaller than V1. Look here, this is A1. What is A1? Cross-sectional area of this hole. What is A2? Cross-sectional area of the top. I told you that's a very tiny hole. It's a tiny hole as compared to the top. You can see that this A1 upon A2 is very small. And if A1 upon A2 is very small, then you are saying that V2 is very small as compared to V1. कोई स्पेशल चीज नहीं, आप खुद भी देख सकते हो. Just have a bottle. You don't have to puncture a bucket or a tank. You can simply use a cold drink bottle and do what? Fill the bottle with water, make a very tiny hole, and as water comes out, try to see the speed of the top surface. You will find that it is coming down, but that speed is much smaller than the speed of water coming out. Easy task hai. Maths is also giving us same thing, but with the help of continuity theorem. Now, let's use Bernoulli. This is continuity. Let's use Bernoulli. Bernoulli tells us what? This P1 plus half rho V1 square, but this time we are talking about two places which are not at the same height. While dealing with Venturi meter, we are dealing with two cross sections which were at same height. But now these two cross sections are at different heights. P1 plus half rho V1 square plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. Now, I'll ask you a very important thing, a very fundamental part of this Bernoulli. P1 is pressure at this cross section. P2 is pressure at this cross section. Ulta. This is A1, so take this as P1 and take this as P2. This is a P2, this is a P1. Which one is correct? P1 is P2. P1 is greater than P2. P1 is less than P2. What do you think is the correct thing? A, B, or this C? Let's see how many of you can answer this part. P2, P1. We're using Bernoulli. This is P1 and this is P2, and I'm asking you which of three is the correct one. Note down this much and try to answer this. Well, that's what I expected from you, that everybody is going to answer that P1 is greater than P2. और इसीलिए मैंने आपसे पूछा भी था. लेकिन आपको जानकर खुशी होगी कि ये आंसर गलत है। And the correct answer is P1 equal to P2. P1 is equal to P2. कैसे? इसीलिए इस क्वेश्चन को दिया हुआ है अपन ने, इसीलिए अपन टॉरिसेली को डेवलप कर रहे हैं. This thing will help us in understanding Bernoulli's equation. First note down this, make a cross because this is the obvious one. आदमी को क्या लगता है, अरे इतनी हाइट है, प्रेशर ज्यादा होगा. Immediately they go for P1 greater than P2. But if you can, you should in fact, if you can see the notes, in the notes of Bernoulli, just go and see the way P1 and P2 were working. The moment you see the way P1 and P2 were working, you will understand why option A is correct. Go and see the notes of Bernoulli's when I gave you the derivation. And if you, by any chance, by looking at the notes, can understand this, then write yes in the comment box. Remember, I can ask you, if you write yes, then I may ask you, tell me how come A is correct. So make sure you watch the notes and then only you write yes in the comment box. Not a single person has the first one. The one is saying yes. Let me draw the figure and then I'm still giving you time. If you can understand that P1 equals to P2, then you will write yes in the comment box. And it will be better if you give me a reason behind that yes. Instead of simply writing yes, if you can also give me an idea that this is the reason you think P1 should be equal to P2, it would be much better. By the way P1 and P2 were used in Bernoulli was in this form. This was P1, this was P2. One of you has answered something. Well, the first response is entirely correct. Both say good. The first response, let me read out the response. Atmospheric pressure is acting at both the places. That's why P1 equals to P2, because it's an open vessel. Statement is correct, लेकिन इस स्टेटमेंट को थोड़ी और डेप्थ देते हैं. And that depth was already present when I taught you derivation of Bernoulli's equation. शायद आपको याद हो कि यहां पर एक फोर्स लग रहा था F1 और यहां से एक फोर्स आ रहा था F2, and corresponding to F1 and F2 pressures are P1 and P2. सबसे इंपॉर्टेंट चीज, इस F1 और इस F2 को हमने क्या बोला हुआ था? External. These were external forces. We found their work and then that work was equal to change in kinetic plus change in potential energy, which gave us this equation. Important part क्या है? Important part है this force and this force, these are external forces. Now if you look at this liquid, it has this type of shape. शायद दिख रहा होगा. Top cross section and the water is coming out. What are external pressures? जो चीज यहां से पुश कर रही है, that's P2. जो चीज यहां से पुश कर रही है, that's your P1. आपने क्या सोचा? आपने ये सोचा कि भाई ये हाइट h है, तो यहां का प्रेशर क्या होगा? h रो g. आपने क्या सोचा कि इस डेप्थ पर प्रेशर ज्यादा है, दैट इज इंटरनल प्रेशर. हम जिस P1 P2 की बात करते हैं, these are because of these external forces. So when you talk about P1 and P2, remember they are external pressures. आपको क्या लगा था? हाइट यहां से यहां पर जब पहुंचेंगे तो यहां तक जाकर लिक्विड हमें अच्छे से पुश कर रहा होगा. दैट इज इंटरनल प्रेशर. Pressure coming from this side and pressure coming from this side, these are atmospheric pressures. अगर एटमॉस्फेयर नहीं है तो फिर जीरो. This P1 is also P atmospheric pressure. Atmospheric pressure. यहां और यहां दोनों जगह पर एटमॉस्फेरिक प्रेशर क्या है? सेम. इतना बड़ा हमने टैंक नहीं लिया हुआ है कि उसकी हाइट हो 20 किलोमीटर्स. अगर आप बहुत ज्यादा हाइट का टैंक लोगे तो फिर यहां और यहां का एटमॉस्फेरिक प्रेशर भी क्या हो जाएगा? चेंज. नॉर्मल कंडीशन में आपको पता है कि एट दिस प्लेस एंड एट दिस प्लेस atmospheric pressure will be what? Same, and therefore P1 and P2 they are equal. तो जब आपने आंसर दिया था B, तो आपके दिमाग में क्या चल रहा था? ये डीप है, प्रेशर ज्यादा होगा. शैलो प्लेस, प्रेशर कम होगा. आप इंटरनल सोच रहे थे. Bernoulli says this and this, there are what? External pressures acting on this. External pressure at both places. Atmosphere is pushing. Atmosphere is only pushing from this side also. And therefore, option A is correct. Before I complete the derivation, if you understand this concept of atmospheric pressure and why P1 is P2, they both are same. Write down yes in the comment box and note down everything. Don't forget to draw this figure also as a side note. One of you is asking that, sir, if the tank is closed. Well, if tank is closed, in a sense that as water comes out, it creates a vacuum on top. Then you know that because of that vacuum, pressure at the top will be less. The way you're asking the question, the way I understand your question, if tank is closed from the top, if you're asking that, as water comes out, if it's closed, first of all the air inside, let's assume that it was at the atmospheric pressure at the beginning. Now, as the water comes out, it creates what? A vacuum sort of. You can visualize that. Because of that vacuum, P2 will decrease the pressure. And in that case, you cannot use P1 equals to P2. In that case, you have to continuously decrease P2. If tank is open, throughout movement of water, pressure on both sides will remain what? Same. Are you comfortable with this? Good. So let's continue with this. The Ignavi. What is P1? Let's call this P atmospheric pressure as P naught in short. This P, let's call it P naught. This P1 is P naught plus half rho V1 square plus rho G. Now, what is H1? H1 is height of this place from the ground. H2 is height of this place from the ground. Let's take ground at the bottom of the tank. जब अपन ये H1, H2 लेते थे तो अपन क्या करते थे, एक ग्राउंड लेवल डिफाइन करते हैं, उस ग्राउंड से यहां तक की हाइट, ग्राउंड से यहां तक की हाइट, हमने बोला कि भाई यही ग्राउंड है हमारा. If this is the ground, at the bottom of the tank is the ground, then what is H1? 0. That's what I'm using. Rho G H1 is 0. This is H1. P naught P2 plus half rho V2 square. Now let's again use what? A shortcut. You can see that V2 is much smaller than V1 because A2 is much larger than A1. A2 is much larger and therefore V2 is much smaller than V1. If V2 is much smaller than V1, then it also tells you that V2 square will be even much smaller than V1 square. अगर 1000 से छोटा है तो 1 square 1 and 1000 square 10 to the power 6 और भी बड़ा क्या आ जाएगा, separation दोनों के बीच में. And therefore, for all practical reasons, I can say that this V2 square is almost what? 0. This is V1 square, but this term of V2, because of this, coming from this, because of this, is almost 0. Plus rho G height of this part. This is the ground. I told you the base is what? The ground. What is this height? H. Write down H. And I hope you see that we have got the value of root 2 GH. P naught cancelled. Rho G0 gone. This gone. Cancel the term of rho, cancel the term of rho. And this immediately gives us V1 as root over 2GH. Cancel P naught and P naught. This is gone. Rho cancelled. V1 square is coming GH. And you have a term of 2 as 1 upon 2. Shift it there. And you arrive at V1 equals root 2 GH, which is Torricelli's law. if you understand the entire derivation, things like P naught, P naught, things like 0 because of H1 being 0, 0 because of V2 being very small. If you understand all these things, then write down yes in the comment box. But how do you understand it? You're saying that, one of you is saying that board is blurred. And many of you are saying yes. The board just became blurred. Maybe before that you could understand everything. That's what you are saying. Those who are saying yes, they could see everything before the board became blurred. Good. Just give me some time. Let me change the connection first. Well, is it clear now? Those who found that board is not clear, is it clear or what? Yes, it's clear now. Okay. Write down few points. Well, one of you is asking that how come H1 is 0. So you can write a statement for that. H1 and H2, they are taken from a given ground frame. You have a reference. So if you wish, you can take that reference over here. You can take that reference anywhere. We have taken that base level at the bottom of the beaker or tank itself. So write down this H1 and H2, H1 and H2 are taken from the base of the tank itself. H1 and H2 are taken from the base of the beaker itself or tank itself. Therefore, H1 is 0. Therefore, H1 is 0 and H2 is H. Second statement. In Bernoulli, P1 and P2 In Bernoulli, P1 and P2 are the external pressures. In Bernoulli, P1 and P2 are the external pressures and therefore for an open tank both will be same. Inside the bracket, equal to the atmospheric pressure. Equal to the atmospheric pressure. Next point. Velocity at the top of the tank can be considered almost zero. Velocity at the top of the tank can be considered almost zero as long as hole through which liquid is coming out is sufficiently small. Now, just a small last example. Let's see how many of you will be able to answer it. We have a tank and height of the tank is 10 meters. A tiny hole is made at a height of 2 meters. First of all, tell me, what is H? 2, 10, 6, 8. Answer this part fast in the comment box. When I write V equals root 2 GH, which H should I use? While using V equals root 2 GH, which H should I use? 2, 10, 6, 8. Answer this part fast. Good. What is H? This height above the tiny hole of the free surface. So this is your H. This much. which in this case is what? 10 minus 2, that is 8 meters. So this is the first thing. The second part, as water comes out, it lands over here. At what distance from the base this water jet is going to land? Find me this distance. A very basic question. You have a tank, you made a tiny hole at some depth, water leaks out. Where exactly it lands from the base, that's what the question is. To give you a hint, I'm asking you, look at the hint, I'm asking you R. Let's see how many of you can answer this. Well, it looks that board is quite blurred. There seems to be some problem with the connection. Let me answer this and then I will send you the recording. So those of you who find that they cannot see the board clearly, don't worry. You will get the recording of the whole thing. You're looking for range. You cannot use u square sine 2 theta upon g. You cannot use this formula. This is used for ground to ground projection. The formula which we need to use is u times root over 2h by g. There are so many h, you need to be careful. This h, when you use projectile motion, horizontal projection, this h in that formula is this height. Just to avoid confusion, I am using h dash. In root 2gh for Torricelli, this is the height. Whereas in the formula of range, height which you take is height from the ground, which is h dash. U is root 2gh, root 2gh, which is 8. This is this h, multiplied by 2 into h dash, which is 2, divided by g, 10. You can see that 10 and 10 gone. This is what 8 to 16 to 32 to 64, which is giving you 8 meter if everything is correct. Root 2gh, 2 into h dash, height from the ground. 10, 10 cancel. 8 to 16 to 30 to 64. Square root of 64 is what? 8. If you can see the board and if you understand this 8 meter, write down yes in the comment box and then you can leave. Thank you very much.